one more time.
Okay.
It's Marcin from Allegro. He will show how we deploy apps in our stack.
Before I start, I want to ask, do you like details? Do you like details? Because I prepared a lot of sneaky details about our development. So, can we start? My name is Marcin Kliks. I work at Allegro Group writing software for data center, which automates our infrastructure. Our goal is to give developers power they need in the form of some nice API. So over the years I created some open source projects that you can find familiar. And I will talk about continuous delivery in practice. In practice. It's not about books, it's about practice. So how you can release and deploy every day. And I will talk about feedback loops, which I think are essential in the process of continuous delivery. So, new term, feedback loops, remember. So, our infrastructure operations are about 90% based on software. So, from the beginning, it was really hard to automate deployment. So, we were really interested in solving the problem of continuous delivery. And what means continuous delivery? Continuous delivery is hard because how can you do multiple releases a day? How can you do it without worrying about the stability? How to test it? And when we think about continuous delivery, we think about continuous improvements. We want to be ahead of the market. And everybody wants to ship fast. And this is, for example, how Microsoft see it. They have shipping awards for employees to motivate them to ship fast. And I don't think it's the best solution for continuous delivery to give the awards. So we are looking for something different. As you know, Scrum was invented, for example, also to ship fast. Microservices were invented to ship fast. And everybody wants to ship fast to production. It's our industry obsession. But how to do it? Okay, I have a simple answer. It's called Allegro Engine. But wait, it's not the complete answer. Because we have deployment platform at Allegro Group, and it's great, and I will show you today. But before I show you this, I'd like to say that there is no magic software or magic button to enable continuous delivery. No such thing exists. It's much harder than you think, because the crucial thing is not to deploy, but deploy without breaking things. You don't want to deploy and break things. And breaking things is quite easy in a complex environment, such as microservices architecture. So, what can we do about it? Over the years, I observed that the essential thing that enables continuous delivery is fast feedback loop. Software life cycle consists of feedback loops. Companies which has long feedback loops can't release often, even if they have modern deployment platform. So let's take a look how our feedback loops work in practice. I know that it kind of looks complicated, but it's really easy. So the feedback loops triangle covers the entire release process from the bottom, we see development, and up to deployment and gathering feedback from the end users. It's up. And as you can see, the higher position in a tree, the time to get feedback is longer. And when you code, the feedback is seconds from your code editor. But the end user feedback can take days or months. So what can we do about it? Let's think about it. Let's start with the code editing feedback. And you spend 90% of your time in the code editor. And every optimization here makes sense. You want to handle every possible error before putting it into production, right? And in case of Python, you have some advantages because there is no compilation step, but Python is so dynamic in nature that you can't easily detect most of the errors. And on the better side, you still don't have a compilation step which can slow you down. And of course, there are some great linting solutions that can help you here, but it's not a magic solution. And Python 3.5 type annotations promises to help, but it's still during the development. Other programming languages, for example, Scala, that takes a long time to compile, so the feedback loops is longer, and this could be a problem. This is the reason some programming languages got some momentum, even if they don't offer complete features. For example, Golang, and they compile so quickly that that's your advantage, because feedback loop is essential. And the magic happens when your compilation speed is fast, and at the same time, language compiler can find memory leaks, can detect complexity of your expressions, and also detecting race conditions. So that's great. For example, Swift is such a language. I think this is the key to continuous delivery, to do it fast. It really matters because you work with your code almost entire day. The second thing about coding feedbacks is to develop in isolated environments. So we provide such an isolated environment as previously we've seen the presentation about Vagrant. So we also use Vagrant in our company. Of course, Vagrant is slow as hell, but we use it because Docker Compose is faster, but it is not ready, so fuck you. And feedback loops, let's go back for a second to our diagram. Let's assume we have lightning fast compilation, linting and bugs detection. 100 times a day we got fast response. Now let's take a look at unit testing. And typical problems are long-running unit test, and sometimes you cannot run it locally, or sometimes it's broken. But we won't cover the last problem here. Our approach is to have it running under 5 minutes. When it takes longer, the developers tend to skip some tests. The second thing is to have a simple command to run entire suite. We use Travis for our data center software because of the open source nature, and we plan to adopt Travis in our closed sources as well, because it plays well with the rest of the ecosystem. And we use coveralls for code coverage, and many Travis plugins for code quality checks. So the important thing is to have your CI plans define code, not in your build to graphical user interface. It's very important. And because you can version it, you can review it, modify it, and store safely in your source code. So software-defined build plans. Let's talk about integration tests. Please bear with me. So they are slow by design, and Travis can run some of the functional tests or even integration tests. We test our code against many different Django versions and databases using matrix Travis configurations. And Travis works fine with Docker, so you will spawn additional software in the same version you use in your production. So you can use Docker to run Postgres and MySQL. But in our particular case, integration tests are really challenging for data center software. For example, when we write software for F5 load balancer, we need separate instance just for integration tests. In this case, we create pre-production environments simpler cases, for example, DHCP or DNS, we use Docker to replicate production environment. This is an example of a replica of production environment using Circle CI. So here we use Circle CI for testing our DNS systems API. In the Docker image, we spawn real DNS server and we do end-to-end testing of it. So it works really good. We have no issues with it whatsoever. So Circle CI. Remember that integration test and end-to-end testing can take a lot of time, and Docker images are big too, so you can build it in parallel, but it's still an issue. Next problem with integration tests are overmocking, so it's really easy to overmock and forget about the problem, but you don't test it then. And if you do it right, your integration test can take up to 30% of your development time in some cases. And in case of microservices, testing could be really hard, and in some cases only testing in production can save you. But I will talk about it another time, because microservices is a huge topic, so I want to cover it in this presentation. The next level is code review feedback. Do you do code review? Anyone? Very good. So that's important thing. Our approach is to review not only code, but design, bigger picture, architecture, potential problems, code style. That's essential, not your just code style. So our approach is to design first. And what does it mean? We use something like technical proposals. It's just a document where you describe the change and want to receive comments, and other teams can learn in advance about the potential changes. In this particular case, we see rough extension proposals, which cover the changes before code is even done. So we discuss, we create proposals, and for example, Rough is developed by not only Allegro teams, but mBank also uses it. So it's really important to synchronize different teams around one project. In the microservices world, it's even more essential, because your feature doesn't cover one microservice. It's about bigger design. So it's really important here. So what happens after proposal? After you agree on a proposal? Our approach is that we start developing, making pull requests in advance. So there's a lot of work in progress pull requests with WIP labels. And the advantage is to get feedback during the development without making extreme programming. So this is a kind of feedback loop you really want. So you can comment and change your mind on every step of development. And you can watch sources being written. After the work, of course, your commits get automatically squashed by Travis, and it's done automatically. So we believe the cost of change during design phase or initial development is quite low, and the feedback loop here makes a lot of sense. You read what you saw. But that's not all we got here during the development phase. We have a tool called Octodocker that allows to test pull requests even before it's merged. So you get additional feedback of running code before it's being merged. The tool is really simple. It runs Docker on given branch or given pull request, and you can interact with the live system just to not only see the code, but test it in real if there's no problems. So it's Octodocker, and we are going to open source it next week. Yes, Mateusz?
We hope so.
Yeah, we hope so. And there are a lot of challenges during the development. You know it, modular architecture and so on and so on. So it's just a part of our day of developers. So feedback loop during the development is very important if you want to ship fast. And so your code is now tested, you got feedback on every possible level, and you are ready to just push it to production. So this is the sexy part. This is the sexy part of my presentation about deployment platform. So how do you deploy? And our new production code is entirely based on Allegro App Engine. Our platform is called Allegro App Engine. Currently, it serves over 1,000 containers. It's based on Mesos and Marathon. For low-level infrastructure services, we use Debian packages because it makes sense for low-level services to not rely on high-level services. And we also use Docker some in a medium somewhere. So let me introduce Allegro App Engine now. Our main deployment platform is based on Mesos, as I said, Marathon and Docker, and Marathon is our scheduler. We frequently commit to the Mesos and Marathon to customize it to our needs, and in our approach, we decided to build wrapper around Marathon to keep deployment configuration in code. So you don't have direct access to the Marathon API. You write your deployment configuration in such a code. And to deploy the service to production, you need this configuration file. It's always safely stored in the CVS. And it's even auto-created for you from the template. And let's see what we got here. It's a command. There's a command to run your service, and it doesn't matter what the programming language it's written in. We mostly use Java, but support other languages as well, such as Python, Node.js, and so on. As we can see, you can define resources, such as CPUs, memory you want, and it's basically unlimited. And health checks are used for auto-healing your container in case of outages. It can also respawn your container if they don't respond to HTTP checks. So you can define it here. Build command is used for creating artifacts, and Docker is one of our artifacts. You can choose native build as well. And in short, we are using our Mesos serving over 1,000 containers, as you know, Mesos can be installed on any platform. So we use OpenStack or bare metal platform to host it. You have choice to be native or Docker package, and we have separate development, testing, and production clusters. There are some limitations when it comes to Docker to keep it simple and fast, because as we all know, Docker is not so stable as they say. So we've chosen to take one base image and block it Docker Hub for security. We don't use volumes provided by Docker, and we patch it, rebuilding the containers from scratch. Also size limitations, because Docker images tends to be very big. So we decided to limit it around 300 megabytes, and it's doable, trust me. So another nice feature is that we've built a engine console to be the central place for creating new projects. So even the part of creating configuration file is fully automated, so you can generate new apps from the templates. And we support many runtimes which runs as microservices, for example Python. And let's take a look at the microservice just after being created. And it has many features enabled, so you are ready to go. You have access to our infrastructure's APIs, including secure configuration, testing and deployment environments, scaling and auto-healing, and many more services that are classified. So it's so simple to create new service that sometimes we can't organize it good enough and get the big picture, because it's so easy to create new service that our developers tend to create it like crazy. So we are working on limiting their creativity. But on the bonus side, you get some nice monitoring templates based on Grafana and internal solutions. So this deployment platform solves a lot of problems. Scaling and auto-healing, so you can scale just infinitely up to 50,000 cores as we have. You can have repeatable deployment. You can have immutable infrastructure, and it's great, but it doesn't solve microservice testing, dependencies and complexity, network and performance, and of course feedback loops that are essential to deliver in a fast manner. And it introduces even more problems, another layer of complexity. So you have to cope with another layer which need maintenance, performance tuning. And even though our deployment platform gives us flexibility, we are still working on a demanding microservices architecture with its problems. And we've learned a lot of open source model and want to adopt these tools. And focusing on platform performance, tight feedback loops, internal open source model, and better end-to-end testing. Code tourism is another term which focuses on tight feedback loops between the teams. So these are the things we are working on, and deployment platform really helps here. So that's it. I hope you liked it. Feel free to ask me any questions about feedback loops and our deployment platform. Thank you.
Do you use Zabbix inside the containers to monitor the services?
We use Zabbix, of course, outside containers, and we are injecting some type of script into containers to just push the monitoring data outside of the container. So that's our solution, how we integrate Zabbix. Okay.
Many services depends on stateful, other stateful services like databases. How do you do database schema upgrades?
Oh, it's really complex. So how do we manage the schema upgrades? I really like the question. In the first place, you shouldn't done it. And it depends. Our company has a great NoSQL storages, and we are focusing on it. Schema upgrades is something out of the process. So we divide the deployments in separate stages. So we focus on iterative deployments, which doesn't need schema upgrades. So it's different fast path for deployment. And schema upgrades, which are treated as another less frequent action. So we just, divide it and focus not to make schema upgrades so often. Thank you. Okay. You?
Do you use green deployments for using
PagerDuty?
green blue deployment
yeah.
for user feedback?
Do we use it? Not currently. It depends. As always. I would say we are going to this place where all of our teams and mobile apps and web apps are blue-green deployments enabled. So we are going into this place, but we are in the process. Yeah. Okay.
I have a question about October, right?
Yeah.
Why do you have to develop your own tool and not use something like Jenkins and Docker?
Why not use Jenkins for testing our pull requests?
Yes.
And do Jenkins can you run given part of code in Jenkins like long-running code, not just the unit test? Because it's our case that we have Travis for just unit test, and we built a tool to automatically merge your pull request and run it, and it exposes some HTTP ports, so you can log into the system and do behavior tests on it.
Yes, sure. You can do this with Jenkins because of the plugins that will do this for you.
Okay.
Like based on Git repo, will pull down the request and run the jobs on top of it. So it's kind of important. So why do you have to develop your own tool?
Probably the reason was we used Travis, and Travis doesn't have this plugin, but I'm open to discuss later because it's really interesting.
Okay, thank you.
I have a question.
I have a question. Okay, let me give you mine.
Okay. Yeah, I would like to come back to the same question because in Jenkins you have this version 2.0 that allows you to code using Jenkins file, using Groovy, for example. And the question is, but the same, because you can do this exactly in such a way that you can write the Groovy code and you can implement the customized version of what you really need there. So this is, you can build Docker images and do a deployment and test automation using Docker images. So I don't know the Travis, I didn't have experience with it, but from this perspective, you can do it in a different way, I would say.
Okay. So it's really nice. It's partly why we didn't go this route to test Jenkins was that open source nature of our code requires to use some open source ready to use and tested solutions. And when we decided to choose Travis, it was like 5 years ago. There was no such a solutions available that we could use.
This is quite new because it's April this year. Workflow plugin and pipelining, so it's something new. But it allows you to do some customization on top of Jenkins using Groovy language or other programming languages. So it's quite good.
Thank you for it. I will play with a bit. Another questions? Okay.
So you said that you have both native applications and Docker applications in your Mesos cluster. Is there any advantage of using native, or is it due to lack of some features in Docker? What's the reason behind that?
So the question was why we use native Mesos executor instead of just diving into Docker completely. And the reason is that at first we adopted a native solution, and it played well because we use mostly Java, and Java doesn't update so frequently that as Node.js, for example, every Monday you have new release of Node.js, so fuck you. So in our case, that was not a problem. When we adopted new programming languages in our deployment platform, such as Python, Node.js, and so on, we needed a solution for frequent updates on Mesos clusters. So currently Docker is like 20% adoption rate versus 80%, I would say. So it might change in the future.
I have a different question.
Okay.
So I have a question about the code tourism. So like in big companies, it's usually a huge problem because you have the specialization and not always your manager is happy that you're kind of playing with different codes. So how do you correct that in Allegro to do the code tourism?
Okay, so our approach is it's also a hard question. How do we do tourism? And I think the key is to have a strong code ownership. So when you do microservice, you are the owner of the microservice, and your responsibility is to manage architecture of this microservice, but you should be able to merge pull requests from other teams. So this is not losing the ownership. So you forget about your microservices, and it becomes a nightmare to manage. You are responsible to be architect of your microservice, and you can merge pull requests from other teams. So it's like a balanced approach. And of course, if you do design, so you write blueprint for a new functionality for Allegro Group, and if you do it right, you will identify microservices to change. It will stimulate you to do correct tourism approach. But we are learning it. This is the open source strategy that works fine, and we want to adopt it in our internal teams also.
Yeah, I just have one comment there. It's like, I think if you treat your internal projects like every open source project, then it works better for the code tourism. Yeah, that's cool. I like it very much.
We touched one sensitive question, how we do code refactoring and how do we do collaboration inside team. As many projects is not related to one person. Many people can work on one single project.
So how do we do refactoring in our teams? We have over 100 teams at Allegro Group, development teams. So I can speak of myself. I just do it. Okay, I just do refactoring. You do it every Monday when Node.js ship.
The problem is when you do reviews, you just merge code, and then later there will be a big technical debt. So refactor is essential, and it's not covered by blueprint or some other documents. Someone just needs to look through code and just do refactoring.
Okay, so when you do it right, in theory you shouldn't need to do some crazy refactoring every week. So I would say when you choose correct architecture, it will be no problem at all. When you are reasoning about your architecture design, there will be no problem at all to deploy it and develop it further. I lost one more thing.
Let me help you a bit because I work with Marcin. So we focus also strong on a quality and a culture of code development and code shipping. So one of the factors that we don't get lost in both microservices world is strong ownership and very clear and well defined. So we use such a thing like a service catalog, so we know who is the owner of this ship that was being developed and shipped. This is one thing. The other thing we do is we have a team of people, which is not an official team, like a code quality keepers, that were focused in the past only on the code quality. So they were looking for nasty code, and people could ask them for a review of their code. And right now they take care also about the architecture and the technologies being used. And it's not an official team, it's like a team of best engineers in the company, and all the people in the company know these are the people that you can ask any question. So we try to develop and build this culture of good quality, and it's not about blaming people in the end, it's about shame that you shipped something shameful or shitty code. Yeah, that's it. So it's, Allegro is a very technical organization. By the way, it does money, but it's very technology oriented, and being poor engineer, it's a hard life at Allegro.
How do you get managers on this thing to think about and getting budgets or getting time or getting attention?
You mean attention on code or?
No, attention from people maybe more, because you need attention to
Okay, so it starts at the very beginning on the recruitment process. In the past, we had a very traditional recruitment process with agencies, with companies that brought us some people, but we changed very much our recruitment process. So we filtered a lot, lots of people, and it's pretty hard to get through because there are lots of steps going through the engineers, through the test cases, through the tasks, through the challenges, and it's pretty hard. I'm not sure I would be able to get into Allegro right now. I'm lucky enough, I've been for many years.
That's good.
So it starts at the very beginning. So we get really good people right now on the board, so they, rise the bar very much. And it goes, so it's, this culture of high quality code, it's a shame to ship shitty code right now.
I understand that the technical people get the problem, but sometimes the management don't get it. How do you involve the business, the management?
Same, the recruitment process for the management.
As you mentioned, so we had a product department and a technology department, and since half a year, we have got one department that combines product and technology. So we are responsible for the product and technology underneath it. So you cannot say right now it's their fault or it's their fault. We are responsible for what we are delivering. And there are business people outside also right now. So business people, let's say product owners. So this is one team right now under one supervision of our CTO, who is the head of product people and technology people. So we've got nobody to blame but ourselves.
Okay, so thank you very much.
There's another one.
One small question.
Okay.
You mentioned auto-scaling in this platform. Do you support several data centers?
Of course we do.
And how do you do the transition of the state between data centers?
So we have, when you deploy your service, and as I said, we have opinionated way to deploy the service. So every time you deploy it, It's deployed in 2 data centers at once. So you have a backup for your service when one data center goes down, go fire, and you have a backup. So that's our solution. And what else can I say? Please ask me about the
All
details.
configuration, all like databases, they're all inside one application.
Yes. So when you deploy the container, it contains a configuration, and we inject environment variables, and in environment variables we set data centers addresses. So you can have 2 separate replicas and 2 different data centers. That's our approach.
How do you?
How do the attacks
do you-
migrate between data centers? How they do know which one?
I think this is different.
In case of network partitioning.
That's a good question. And Mesos, we even tested it with Mesos, and yes, it's quite complex. So when you have 2 separated Mesos clusters, yes.
You know, you have to be aware that it's, Allegro is like a 99, so it's 70 years old platform. So it's a lot of different technologies and architectures being used through the time. The Mesos is the last thing that we are using since 2 years, I think, more or less. So when you look at different areas, there are different technologies and approaches being used. So in some cases, the Mesos is the right thing, but underneath, then this is nothing secret. We use Oracle with AIX, P-Series, and rack clusters. So underneath there is a one database or cluster of databases that I'm the master, I'm the slave. So failover is pretty obvious. It's good old technology on P-Series, IBMs, AIX, Oracle, rack, and usually works. Okay, so guys, just so you know, let's talk afterwards. There's a pizza. Let's have a 10 minutes break. So just grab a pizza. Let's get it to the tables and keep on moving.